So question 5, we have an application. A golf ball is hit with an initial velocity of 130 feet per second at an inclination of 45 degrees to the horizontal. In physics, it is established that the height h of the golf ball is given by the function h of x equals negative 32x squared divided by 130 squared plus x, where x is the horizontal distance that the golf ball has traveled, completes parts A through G. So again, what you're looking at basically from a drawing point of view is you have the horizontal, and a 45 degree is kind of something like this here. So the ball is going to take off in this kind of direction. And then as it goes, gravity is going to pull it back down and pull it back down. So the force of gravity will slow it down and pull it back down to the ground. So that's kind of what we're looking at as far as the golf ball goes. So the initial velocity is 130 feet per second. So if you think of if you ever watched somebody hit a golf ball, that's rather quick per second, not per hour or per minute for that matter. So anyway, first question says, determine the height of the ball after the ball has traveled 100 feet. So that's going to be its horizontal distance is 100 feet. So we want to know how far the ball has gone after it's traveled 100 feet. So the way we can do this is we can actually just evaluate the function h of 100. So h of 100 will tell us how high the ball actually is off the ground. So it's going to be a negative 32 times 100 squared over 130 squared plus then 100. So all I really got to do is just put this into the formula. I'm going to go ahead and use the fraction button there on this. I'm going to put the whole thing in at once. So I'm going to hit the alpha button, and then there's a screen F1 up here. I hit that, it gives me this menu. Gives me that. So negative 32, and then in parentheses, 100 goes in, close parenthesis, square that. Go to the bottom, and I should have 130 squared, and then plus 100. So it says round to 2 decimal places. So I need to go ahead and just change this to a decimal. So if I hit the math button, change it to a decimal is number 2. So that gives me like 81.06 or 07. Well, since there's a 5 after the 6, that means we're going to round up. So 81.07 would be what we'd be looking for there. So around 81 feet up in the air. So the next question is, what is the height? Well, what they want to do is evaluate h of 350, interpret this value. So notice again, the x is going to be the horizontal distance. So the x is going to be the 350 feet. That's how far the ball has traveled horizontally. And what we want to do is figure out how high the ball is in the air. So remember, this is an input value, and we're trying to find the output value. So if we substitute that into the function, the 350, so we're going to have this h of 350 is going to equal then this negative 32 times this 350 squared over 130 squared, that was that initial velocity, plus then this 350. That's the kind of math that we're doing here. So again, on my key, there's also a little shortcut here on this button here. If you notice, there's this little square box over a square box. If you've got that, that's a shortcut to that fraction button. So if I hit the alpha key and hit this button, it also gives me that little menu. So negative 32 goes on the top, and then in parentheses, 350 goes inside there, and I'm squaring that. And then the 130 squared is on the bottom. And then we're adding 350 to that. And that gives us then a fraction, but we want that as a decimal. So the math button in number 2 will turn that back to a decimal. So it'll give me 118.04, but it says round to decimal places. So we have to actually look at the 7. The 7 means that 4 is going to go ahead and round up to a 5. So 118.05 would be that. So that's going to be our answer there, 118.05. Now, as far as what that means is, the 350 is how far I traveled, and the 118.05 is the height above the ground. So if we're trying to interpret this value at a height of 350, the horizontal distance traveled by the ball is that. No, well, the height is actually the 118, so that's backwards. If the height of the ball is traveled, the height of the ball after it's traveled horizontal distance of 350 feet is, that sounds right. That would be 118.05 feet. That's how high it is. So the height of the golf ball after it's traveled a distance of 350 feet is 118.05 feet. That sounds good. So the next question is how far is the ball hit? So what they're asking you is what's the horizontal distance? Now, the catch is what we're doing is the horizontal distance, notice that the height is going to be back on the ground. So how far is the ball hit? Well, that means the y value or the output value has to equal 0. So we're looking for the horizontal distance that matches that. So all we have to do is set this function equal to 0. It's negative 32x squared. So this negative 32x squared over 130 squared plus x has to equal 0. Now, one of the first things we can do is get rid of fractions by multiplying by this 130 squared everywhere. So if I multiply by 130 squared, let's see here. Let's see what we're going to just do this to start with. So 130 squared. So if I multiply by 130 squared, notice that the 130 squares will divide out here, give me this negative 32 x squared. And then the 130 squared is going to multiply to the x and give me 130 squared times x. And that's going to equal then 130 squared times 0 is still going to be 0. The next thing is, I wonder if I can divide everything by negative 32. So I know that a negative 32 divided by negative 32 is going to be x squared. My question is, what's 130 squared divided by a negative 32? So it's actually going to be a decimal. So notice how it does say decimal, so we can keep it in that form. So we're going to have then this x squared minus this 528.125 x equals 0. Notice that there is a GCF here. I can actually factor an x out. So x comes out, and I'm going to have then x comes in, and then I'm going to have this x is going to come out and leave me this 528.125 left in there equals 0. Now remember, to solve a quadratic equation, we set each one of these equal to 0. So if we set x equals 0, well, that means the horizontal distance is going to be 0. That means that's where the ball started with. If we set this x one equal to 0, if we solve that for x, we're going to get x equals 528.125 as that. And since it says round to two decimal places, that's going to be 528.13. So 528.13 would be that. So it also says use a graphing utility to graph the function. Just based on what I'm thinking, it's probably going to, well, all three of these look pretty good because they all make the same thing. But so the first thing I want to do is put this function into the calculator. So if I hit the y equals button, I can clear this function off. Again, I can hit the alpha, or there's another place to find the fraction button is under math. At the math button, if you go all the way over to the right, there's that fraction mode there you can do as well. And then you can do then this negative 32x squared over 130 squared. And then we're going to have then plus x. Now, they actually give us the graphing window. So if I hit the window button, the x min is going to be 0. The x max is going to be 600. And the x scale, as they're saying, goes by 100. The y min was 0. The y max is 140. And the y scale, they're going by 20. So if I hit the graph button, you can kind of see the graph. So that one looks really a whole lot like the first one based on the window. Now, if we wanted to, if we want to look at where it touches the ground over here, we could go to the trace button and see if that gets us something really close to what we had. So let's get like 527, and we got 528.13 algebraically. So that's a pretty good estimation. If I want to get an exact value, there is a calculate button right here. If it's second calculate, an x-intercept is also called a 0. So if I choose number 2, if I go left of that, hit enter. If I go right of that, hit enter. So notice how I'm right of it there. If I enter a third time, notice it does give me this 528.125, which is rounded to 520.13. That would give us the same thing algebraically. We can also do it graphically. Okay. So that's question 5.